Electrical wiring relies on a standardized color code system to ensure safety and consistency. These color codes help electricians and technicians quickly identify the purpose of each wire within a circuit, reducing the risk of errors and accidents. Here's a breakdown of common wire color codes and their applications. Black wires are typically used for hot conductors in 120 volts or 240 volt circuits. Hot conductors carry the electrical current from the power source to the load. Red wires are also used for hot conductors in 120 volts or 240 volt circuits. In some cases, they may indicate a second hot wire in a 240 volt circuit. Blue wires serve as hot conductors, often used for travelers in three-way and four-way switch circuits. Yellow wires are typically used as hot conductors, such as for switch legs to lighting or for phase identification in three-phase systems. White wires are used for neutral conductors. Neutral wires provide a return path for the electrical current, completing the circuit. Green wires are used exclusively for grounding conductors. Ground wires provide a safe path for fault current to return to the source, protecting against electrical shock. Their copper wires are also used for grounding conductors, often found in older installations or for bonding purposes. Firstly, for single-phase 120-volt circuits, the common color codes are black for the hot wire, white for the neutral wire, and green or bare copper for the ground wire. Secondly, for single-phase 240-volt circuits, black and red are typically used for the two hot wires, white for the neutral wire, and green or bare copper for the ground wire. Thirdly, in three-phase systems, the hot wires are often identified as follows: black, red and blue, white for the neutral wire if present, and green or bare copper for the ground wire. It's important to note that specific color code requirements can vary depending on local electrical codes and standards. Always consult the applicable codes and regulations for your jurisdiction. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical wiring and safety. Always refer to the latest edition of the NEC for the most up-to-date information. Different types of electrical wiring may use different color codes. For example, cable assemblies such as non-metallic sheath cable often follow the standard color codes outlined above. Conduit wiring, on the other hand, may allow for more flexibility in color coding, but it's still essential to maintain consistency and proper labeling. When working with electrical wiring, it's crucial to follow safe practices to prevent electrical shock and other hazards. Always to energize circuits before working on them, and use appropriate personal protective equipment, such as insulated gloves and safety glasses. Use a voltage tester to verify that circuits are de-energized before handling any wires. Be sure to properly label all wires and connections to avoid confusion and ensure correct wiring. If you're not comfortable working with electrical wiring, it's best to hire a qualified electrician to do the job. Improper wiring can create serious safety hazards. Here are some additional considerations for specific applications. In residential wiring, the color codes are generally consistent with the standard conventions. However, some variations may occur depending on the age of the installation and local practices. In commercial and industrial wiring, the color codes are even more critical due to the complexity of the electrical systems. Proper labeling and documentation are essential to maintain safety and prevent errors. When working with control circuits, the color codes may differ from those used for power circuits. Be sure to consult the control circuit diagrams and documentation to understand the wiring scheme. It's important to note that some older electrical installations may not adhere to modern color code standards. Exercise caution when working with older wiring and take extra steps to verify the purpose of each wire. If you encounter any unfamiliar wiring configurations, it's best to consult with a qualified electrician. Electrical wire color codes are essential for maintaining safety and consistency in electrical wiring. By understanding these codes and following safe practices, you can reduce the risk of errors and accidents. Always consult the applicable electrical codes and regulations for your jurisdiction, and seek the help of a qualified electrician if you are not comfortable working with electrical wiring. Remember that electrical work can be dangerous, and it's always better to be safe than sorry. Here is a more elaborate listing. Black typically indicates a hot wire carrying a 120 volts or 240 volts current in residential or commercial wiring. It's crucial for powering outlets, switches, and appliances. Red also denotes a hot wire, often used as the second hot wire in 240 volt circuits or for switch loops. In some setups, it might also be for connecting smoke detectors. Blue commonly signifies a hot wire, often used for travelers in 3-way or 4-way switch circuits. It's valuable for complex lighting setups where control is needed from multiple locations. Yellow similarly designates a hot wire, often used as a switch leg to lighting, or for phase identification in 3-phase systems. This color aids in distinguishing circuits within industrial or commercial settings. White is almost universally the neutral wire, providing the return path for electrical current, completing the circuit back to the source. This is vital for the proper functioning of most electrical devices and preventing imbalances. Green is reserved exclusively for ground wires, connecting to grounding points, electrical boxes, and equipment to safely divert fault currents. This protects against electric shock. Bare copper, also for grounding, is sometimes used in older installations or where additional grounding is needed. Its visibility makes it easily identifiable. The NEC mandates adherence to these color codes to ensure safety, prevent accidents, and streamline troubleshooting. For example, NEC 200.6 requires that grounded conductors of 600 volts or less must be identified by a continuous white or gray covering. Similarly, NEC 210.5 specifies the use of specific colors for identifying different phases in multi-wire branch circuits. Correctly identifying wire functions prevents dangerous situations and ensures proper operation. For instance, misidentifying the neutral and ground can lead to shock hazards. The NEC provides specific guidelines on how conductors should be identified. For example, NEC 310.8 requires conductors to be insulated unless specifically permitted otherwise. Also, NEC 408.3 states the requirements for identifying circuits and overcurrent devices in panel boards. Many resources provide in-depth information on wire color coding. Handbooks, online guides, and training manuals offer detailed explanations. Additionally, manufacturers of electrical equipment often provide guidelines for specific applications. Wire color codes can vary slightly based on local amendments to the NEC, so consult local authorities to be sure. For example, some areas might have specific rules for low voltage systems or for wiring in healthcare facilities. Adhering to local codes ensures compliance and safety. The color codes for low voltage systems can differ, so it's important to review specific instructions for these. For example, in some low voltage lighting systems, different colors might be used for different control signals. Using the wrong wire can lead to equipment damage or system malfunction. In summary, understanding and correctly applying white color codes is essential for any electrical work. By following standard practices and consulting the NEC, you can ensure safety and compliance. Also, using reliable resources and staying informed about local codes is important for continuous professional development. Here's an expanded explanation. The black wire's typical use as a hot conductor in 120 volts or 240 volt circuits means it is a primary carrier of electricity from the power source to devices. This wire is often connected to the breaker in the electrical panel and runs to switches, outlets, and light fixtures. Red wires, also hot, are often used as secondary hot wires in 240 volt circuits, like those for electric water heaters or stoves. They can also be used as switch legs or travelers in 3-way and 4-way switch configurations, providing flexibility in controlling lights from multiple locations. Blue wires, serving as hot conductors, are frequently used for travelers and more complex switching systems. Their distinct color helps differentiate them in multi-switch circuits, reducing the chance of miswiring. Yellow wires, primarily hot, are used for switch legs, especially in commercial and industrial environments where phase identification is crucial. This color can also identify the control wires in systems where multiple circuits must be clearly distinguished. White wires, designated as neutral, provide the return path for the electrical current back to the source, completing the circuit. It is important that the white wire is properly connected to the neutral busbar in the electrical panel to prevent imbalances and potential hazards. Green wires, exclusively for grounding, connect electrical enclosures, equipment, and grounding electrodes to provide a low impedance path for fault currents. This path helps trip circuit breakers or ground fault circuit interrupters, or GFCIs, quickly, protecting people from electric shock. Bare copper wires, similarly used for grounding, are often found in older installations or used to bond metallic components. The lack of insulation makes them easily identifiable and ensures a solid, reliable ground connection. NEC standards such as NEC 250 cover grounding and bonding requirements in detail, ensuring that electrical systems are safely grounded. The NEC provides guidelines for proper wire sizing, insulation types, and installation methods. For example, NEC 300 specifies wiring methods, and NEC 310 details conductor requirements for ampacity. Following these guidelines ensures that wiring installations are safe and reliable. Incorrect wiring can have severe consequences, including fire hazards, equipment damage, and electrical shock. For example, reversing the hot and neutral connections can energize the metal chassis of an appliance, creating a shock hazard. Proper labeling and identification of wires is essential for safe and effective troubleshooting and maintenance. This is particularly important in commercial and industrial settings where complex wiring systems are common. Many resources are available to help electricians and technicians stay up to date on wire color codes and best practices. These include the NEC, industry trade publications, and training programs. Staying informed and continuously improving skills is crucial for success in the electrical field. Local electrical codes may have specific requirements or amendments to the NEC, so it is important to consult with local authorities to ensure compliance. These local codes may address unique environmental conditions, building types, or other factors specific to the region. The color codes for low-voltage systems, such as those used for communications, signaling, or control circuits, can differ from those used for power circuits. Always refer to the manufacturer's instructions or consult with a qualified technician to determine the correct wiring scheme. When selecting wires for a particular application, consider factors such as the voltage, current, temperature, and environmental conditions. Choose wires with the appropriate insulation rating and ampacity to ensure safe and reliable operation. Remember that electrical work can be dangerous, and it's always better to be safe than sorry. If you are not comfortable working with electrical wiring, seek the help of a qualified electrician.